Okay, guys, we continue with the second factor, which is effect of pH. Okay, so the enzyme activity is influenced by the pH of the surrounding solution. Generally, all enzymes react most effectively at their optimal pH. So certain enzymes have their own optimal pH. For example, pepsin, the optimal pH is 2. Okay, so this is acidic. Salivary amylase, okay, saliva. Okay, in our saliva there is one enzyme we call it amylase, and most enzymes in animal usually the optimal pH is 7, okay, neutral. Okay, and there is one enzyme here, trypsin. Okay, the optimal pH is at alkaline pH, which is 8 something, 8.2 something. The most enzymes are most active in the range of between pH 6 and 8. Okay, for example, the salivary amylase work at pH 6.8. However, there are some exceptions. For example, pepsin, okay, usually pepsin in our stomach, okay, to act at optimal pH range of between 1.5 and 2.5. So this is the acidic pH. So trypsin enzyme in our duodenum, okay, on the other hand, only work well in alkaline medium. Okay, for example, 8.5. Okay, so that's why pH will affect their activities. So because certain enzymes have their own pH value. Okay, so what happens if there is any changes in pH value? Okay, so the change in pH value changes the charge. Okay, so the word charge here. The ion H plus of the active site of enzyme and the substrate surface. Okay, so any changes in pH value will change the charge in the active site. Okay, as a result, the enzyme substrate complex cannot be formed. Okay, why? Because the substrate cannot complement the shape of the enzyme. When the pH of the environment returns to the optimum level, the charge on the active site will be restored. So the enzyme will return to function as normal. Okay, so if the pH come to optimum again, so the charge will change on the they are restored again, and the active site will be come to the normal condition. Okay, so if the extreme change in pH value, okay, if the change of pH is too extreme, it will break the structural chemistry bond and change the active site of enzyme. So the enzyme can denature. So same case as temperature, more than uh, 40 degrees Celsius. Okay, so this is in extreme change in pH. Not extreme or optimum, they returns to optimum again, so it can return to normal. Okay, so this is the shape of normal enzyme. So if denatured, they don't have their own shape. Okay, next, effect of substrate concentration. Okay, so this is the graph. Okay, rate of reaction. Okay, this is the substrate concentration. Okay, if the concentration of enzyme is fixed while the concentration of substrate is increased, the reaction rate controlled by enzyme will also increase, leading to an increase in product created. Okay, if the enzyme increase, the substrate increase at the same time, so the reaction also increases. Okay, so the rate of reaction increases. Okay, when the substrate concentration increases, the opportunity for an effective collision between the substrate and enzyme molecules also increases, right? So the reaction rate continues to increase until it reaches the maximum level. The rate of reaction is constant. Okay, if the substrate increases, okay, the enzyme increases, so the reaction must be increases. But there is one maximum level here. Okay, if there is not enough enzyme, okay, what happened? Okay, so number 2, at the maximum level, the concentration of enzyme become a limiting factor. Okay, because now there is not enough enzyme. Okay, so the reaction rate can only increase when the concentration in enzyme increases. Okay, so enzyme become limiting factor here. So after reaching the maximum level, all active site of enzyme are saturated with substrate and are involved in catalytic reaction. So maksudnya bila maksimum dah kat sini. No more enzyme. So all enzyme are full, okay, with the substrate. So if we want to increase the rate of reaction, we need to add more enzyme. Okay, last one. The effect of enzyme concentration. The substrate and enzyme, they are best friend. Okay, so if we want to increase the enzyme reaction, okay, we need to get enough enzyme concentration and enough substrate concentration. Okay, when the concentration of enzyme increases, okay, so in this case, enzyme concentration increases, okay, the rate of enzyme reaction will increase because of the presence of more active sites that are ready for catalytic action. Okay, the rate of enzyme reaction will increase because of the presence of more active sites. Okay, so now enzyme increase. So of course there are a lot of active sites. Okay, so if the concentration of an enzyme in one reaction is double, okay, the amount of substrate converted to product per unit of time is also double with the condition that there is an excess supply of substrate. Okay, but number 3, what happened? Okay, at the maximum rate, okay, the concentration of substrate becomes the limiting factor. Okay, because this is enzyme concentration. Okay, enzyme concentration higher but not enough substrate. Okay, so substrate become limiting factor. So the rate of reaction can only be increased by adding more substrate. So same thing. If enzyme increase but not enough substrate, so the reaction cannot be occur. So it become limiting factor for here at the substrate concentration. So if we want to increase the rate of reaction, we need to add more substrate here. Right. Okay. So that's all for this chapter. This chapter is quite simple. So I give you exercises. So please answer first. Then we will discuss during online class. Okay, girls. Bye bye. Okay, bye bye, baby. Bye.